Okay, let's do some problems. So, question number 1. The equation of the asymptote for the graph of log base b x minus 3 plus 2, where b is greater than 0 and b cannot equal 1 is. Okay, looking at this. I first recognize that this is a log. Perfect. They're asking me for the asymptote. Now, ideally, you could just graph this thing, and you could find the asymptote. The problem with trying to graph this thing is it has two unknown things, right? It has an x value right here, and a b value right here, both of which are unknown. So you don't actually have the ability to graph it in its current state. You could make up a b value, graph it, and that would work, but it's not how they intend for you to do the problem. What they're hoping that you'll do for this problem is that you'll recognize that this log graph has actually just been transformed. They've taken the mother function, which is this, and they've transformed it to look like this. I use h and k values to show that these things have been added or subtracted into the function. But we see that? We see how they've just subtracted 3 in there and added 2 out here? Right? Those are transformations. They've added something to the overall function. They've subtracted something from the x value. That means what they've done is they've taken this mother function, this basic function, and they've done something to it. They've stretched it, they've moved it, they've done something. Does anyone remember what these transformations are, what h and k do? Yeah.
Horizontal and vertical translations.
You got it. This 3 value is a horizontal translation. Meaning the graph has moved left or right. Horizontal, left, right. Translation means movement. Okay, I think it's safe to say that that horizontal translation is 3 units. So it's moved 3. Which direction has it moved? Has it moved left? Has it moved right? Yeah.
Right.
It has moved right, correct. It moved 3 units to the right. So remember with our horizontal translations, when we see negative, the negative is actually part of the equation, like our formula for doing transformations. It's the opposite of what it looks, right? So if it's minus 3, most people would think left 3. It's actually right 3. It's the opposite. Cool. That plus 2 is also a transformation. Anyone want to take a stab at what kind of transformation that is?
Upwards.
Yeah, it's an upwards one. We call that a vertical translation. But you are correct. It's moved up or down. So vertical means up or down. Translation means it's moved. I think it's safe to say that that vertical translation is 2. Yeah, so it's 2 units. And you are correct, it is up. So, if your goal was to find the asymptote on this equation, what you could do is you could remember where the asymptote started on the mother function. It started right here on the y-axis. This entire graph, including the asymptote, was then moved 3 units to the right and 2 units up. So it moved 3 over and then 2 up. Meaning my new asymptote would be right here at x equals 3. The answer to that question would be C. The 2 up makes no difference, right? The vertical asymptotes go forever up and down. So you just moved an infinite line. more upwards. It doesn't really make a difference. So really all that mattered there was the 3 to the right. Cool. Let's move on to question 2. The graph of y equals log x is transformed into the graph y minus 4 equals log x plus 5 by a translation of 5 units blank and 4 units blank. The statement above is completed by the information in row, and then you have to choose which one of these would fill the blanks properly. Okay, so you want to go right and up, right and down, or left and down. You have to choose your options for those blanks. Transformations. Transformed. When I do transformations, I like to have y by itself and everything on the other side. And if you look at this question right now, y is not by itself. The y has this minus 4 attached to it. Me personally, I just like to move it over. I like it to be y equals. If you go to your Diploma or one of those other ones, they might do it differently than that. But that's just how I like to handle these questions. So for me, when I look at this problem, the very first thing I do is I get y by itself by moving that 4 to the other side. I'm going to add 4 to both sides of the equation. So I now have this. Y equals log x plus 5 plus 4. Notice that the plus 4 is on the outside of the log. It didn't go in the brackets. It didn't go to the 5. And it's outside the log. If I wanted to describe these transformations, this plus 5 is a horizontal translation. I'm just putting HT. 5 units to the left. Remember that horizontal things are the opposite of what they look like. So plus 5, most people would think right 5. I don't know why. We just assume like positive, you move to the right. Yeah. For transformations, it's opposite. So positive actually means that we're moving that thing left. The plus 4, so anything that's being added or subtracted outside the function is a vertical. So this is vertical translation. And this would be 4 units up, because it's positive. Positive means upwards for our verticals. The correct answer here is B. I moved left and up. Cool. Question 3. For the graph of y equals log b 3x plus 12, where 1 is less than b, the domain is, and they give you all those options. Okay, let's talk about domain. When you see the word domain, they're asking you for possible x values. Graphically, what that means is like how far left and right. That's what domain is. It's possible x values that work for that equation. Graphically, if you're looking at a picture of it, it's how far to the left does your graph go, how far to the right does your graph go. Okay, to do this question, I again have to use transformations. I cannot graph this the way it currently is. The reason I cannot graph it the way it currently is because of this b value, right? My calculator can't handle 2 variables. You could make up a b value, graph it, and that actually would work for this problem. But again, that's like definitely not how they intended it to be done. They want you to use transformations on this thing. They want you to take your mother function. Mother function looks like this. up and over with an asymptote there. And they want you to transform that and figure out what the new domain would be. For the record, my old domain, my mother function, would be x is greater than 0. Want me to write that down? I'll write that down. X is greater than 0. Okay, my new function has been moved. There's been transformations there. The trap that a lot of people will fall into is they'll look at this and they think that they can see the transformations in this form. And you actually can't. So the trap here is that people think it went 12 to the right. And that is incorrect. It did not go 12 to the right. And it also didn't go 12 to the left. That's also incorrect. It didn't go 12. Remember, when we do transformations, we need to factor anything off of the x. So looking at this, to properly get your transformations, I need to GCF that 3 off of the x variable. Then I can actually see what my transformation is. So I go to this, I fix it, it now looks like this. Log base b 3 x plus 4. Alright, I GCF to 3. 3 divided by 3, 3 goes out. I have a 1 left over. 12 divided by 3 is 4. Right, I GCF to 3 out. Now I know what my transformations are. This one is a horizontal stretch. By a factor of 1/3. Not 3. Remember, anything horizontal is the opposite of what it looks. So it's not a factor of 3. I multiplied all my x values by 1/3. Reciprocal. About the y-axis, meaning that when I was stretching it, I was getting closer to or further away from the y-axis. Perfect. Second transformation here is this plus 4. That plus 4 is a horizontal translation. Four units left. Again, horizontal things are opposite of what they look. So normally people would think plus 4 means to the right. It's horizontal. I'm not going to the right. I'm actually going left. So I went 4 left. Connecting this back to domain. That means my new graph roughly would look like this. I stretched it by 1/3, so it's going to come in a little bit. That doesn't make a difference on our domain. The reason it doesn't make a difference on our domain is the asymptote's at 0. 0 times 1/3 is still 0. The maximum is infinity. Infinity times 1/3 is still infinity. It would still go off forever. It's just going to be smushed in a little bit, but it's still going to have an arrow going to the right. And then it went 4 units to the left. So now my graph looks somewhat like this. And I could tell you what my new domain is. My new domain is x is greater than -4. I know it's -4 because this asymptote was at 0. It moved 4 to the left. That means this is -4, and it's bigger than that. Hopefully that's one of the answers. Oh, look, it is. It's always like a nightmare of mine. We feeling okay? Transformations in log graphs, not terrible. We've typically, by this point of the year, like we've gotten pretty good at transformations. Like we did it for so long, right? We did it in every unit, it seems like. And the only unit we didn't do it was perms and comps. There might have been a transformation question in your practice book that I can't remember. Okay, let's do another one. I tried to make that picture look bigger on your booklet because it was kind of blurry. Can you read it okay? So, yeah. Cool. It says a student sketched the graphs of f of x, which equals log base a x plus 3 minus 7, and g of x, which is a to the power of x minus 2 plus 5, where a is greater than 1. Why they told me that actually kind of matters a little bit here, because a is the base here. Alright, so the base could either make growth or decay. It tells you which mother function you're working with here. This is a growth. It's bigger than 1. So it actually makes quite a difference for us here. A lot of the times when they put things in there, it's just like a formality. This one, it might actually help us. It might still be a formality, but it might actually help too. So they sketched that on a coordinate plane. That just means like on an XY axis. She also drew the asymptotes of the two graphs using dotted lines. The intersection point of the two dotted lines will be, the asymptotes are the dotted lines. We want to figure out the intersection of the two dotted lines. So we want to figure out where those asymptotes cross each other. Where do the asymptotes cross? That's what I'm looking for. Okay, the first asymptote is y equals log a x plus 3 minus 7. That's my first graph. If I think about what's happened to that asymptote, just the asymptote, it was on the y-axis. It then moved 3 to the left and 7 down. For a vertical asymptote, moving down makes no difference. The only thing that mattered here is that asymptote was vertical at y equals 0, and it has moved to the left 3. It is now over here at x equals negative 3. The second graph, y equals a x minus 2 plus 5. That is an exponential function. That means the asymptote started on the x-axis, right? It started here. That thing then moved. It was transformed. Things that happen to the x value are horizontal. So this is 2 to the right. It's on the x value, right? They went to the value of x and they subtracted 2 from x. That means it's a horizontal translation. That thing went 2 units to the right. Then they took the overall function, the actual power, and they added 5 to it. That thing is a vertical translation that is 5 units up. Meaning that my asymptote went from the x-axis, it moved 2 to the right, which really doesn't make a difference, and then 5 up. My new asymptote is here. That is y equals 5. This transformation is just trickier to see for some reason. People don't view that as a transformation. It is, right? So what's happened is they took a standard exponential function, they subtracted h, they added k. That's what they've done. H goes directly onto the x value, k goes to the end of the entire function. If you graph them at the same time, they would cross at -3, 5. It's where they intersect. Okay, we'll figure out that one. Yeah, that's good. Those asymptote questions tend to cause a lot of problems when it comes to test time. People try to graph them. They're trying to put graphs down. Try to use transformations the best you can. Okay, number 5. The y-intercept. So the y-intercept on the graph f of x equals a to the power of x plus 1 plus b is to find a y-intercept. Kind of 2 ways you could go about it. Way number 1, my first instinct anytime I see y-intercept, which isn't how I do this question, but my first instinct when I see y-intercept is to remind myself that's when x equals 0. And that will work here. It's just not how I think they wanted you to do the question. But anytime I see y-intercept, I'm like, oh, okay, x is 0. So if I want to solve that y-intercept, I could just go to my equation and change x to be 0, and then see if I could solve it. And that actually works here. So if I go to my equation, f of x is y. Right, same idea. Change x to be 0. So this becomes a to the power of 0 plus 1 plus b. Well, 0 plus 1 is 1. So this is a to the power of 1 plus b. The y-intercept is at a plus b. That ends up actually being a simpler way to do the question. It's actually probably not how I would do the question. But it is a good strategy that when you see y-intercept, you remember x equals 0. Okay, what they wanted you to do, right? And that's a little different than what we did do. Is they wanted you to recognize that this was an exponential function. And on exponential functions, the y-intercept starts at 0, 1. Think back to our exponential graphs. All right, the y-intercept was at 1. Then this thing was transformed. It was transformed 1 unit left, b units up. That's a 1 unit left transformation. And it's plus 1, but because it's horizontal, it's the opposite. So this is minus 1. 1 to the left. This is a vertical transformation. If this was a number, I would say, oh, it went 2 units up, right? But we don't know that value, so we say it went b units up. the y-intercept also moved 1 unit to the left, b units up. So if you started at 0, 1, that then became 1 unit to the left, so 0 minus 1, b units up, 1 plus b. Uh-oh. I'm about to get a different answer here. That's not good. And it's recording. Which is really not good. That's because that's not my y-intercept anymore. You can't do the question like this. See, look, I'm an idiot. The y-intercept on the graph is. My bad. I told you where the y-intercept moved to, not where it is now. Definitely the only way to do this question is x equals 0. My apologies. I showed you where the y-intercept moved to. This would be where the y-intercept now is. Right? The actual y-intercept of this graph is 8. Make x equals 0. That's the easier way to do it. My bad. I apologize. I showed you where it moved to. Y-intercept moved here. But that is not the y-intercept anymore, right? Because the x value is not 0 anymore. It moved to the left. I apologize. Before I move on, I want to make sure everyone's okay with the fact that this is not the y-intercept, because this is not 0 anymore. Transformations would have worked if it wasn't a horizontal transformation, right? And this was 0. But this moved left, which means it's not the y-intercept anymore. Okay with that? My apologies. As soon as I saw that -1 coming, I was like, uh-oh, I made a mistake here. Okay, let's look at number 6. The graph of 3 to the power of x is reflected in the line y equals x. The equation of the transformed graph is, okay, reflected in the line y equals x. That is something that we have seen many times. Anybody remember what that means? Yeah, it means inverse. Right, if something's described as a reflection in the line y equals x, that means they've done the inverse. The inverse means x and y switch places. So I started with this, y equals 3 to the power of x, and it became x equals 3 to the power of y. That's the inverse. That's reflecting something about the line y equals x. I took the x value, I took the y value, I swapped them. Essentially, anywhere you see y, write x. Anywhere you see x, write y. Okay, if you look quickly, that is not the answer. Nowhere in the answer does it say x equals 3 to the power of y. If you look at all your answers are y equals, y equals, y equals, y equals. That means I need to take this thing, and I need to get y by itself. So, I need to isolate y. We have to get y out of the power. To get y out of the exponents, you have to use logs. That's why logs exist. Okay. To get it out, I don't think it's on your formula sheet. That's -2, right? Give me one second. I may get my formula sheet. I don't think it's on your formula sheet. it's not. The dash 2s get to see their log on their front sheet. You guys don't. We write log. The base of your power becomes the base of the log. So the base of the power here is 3. That becomes the base of your log. It's like the little number beside your log. Then you have an argument inside the brackets. The thing inside the brackets is what was on the other side of the equal sign, x. And that will equal whatever your exponent was. Base of the power becomes base of the log. Whatever was on the other side becomes the argument. The exponent is now left by itself. My answer here is log base 3 of x. That means A is the solution. Cool. I think that's standard. Like if I just use letters like A, B, C. So if A equaled B to the power of C, if I want to change that into a log, C is now by itself. It becomes log base B. A becomes the argument. I think they're starting to really slow down on my computer. Not good news for whoever's going to watch a video later. Hopefully it works. Okay. Number 7. A function. Actually, if we go back to this one for a second. I'm trying to think. No, I can't. I was thinking for a second that maybe we could do transformations. Number 7. A function. Y equals A, 2 to the power of bx, passes through the points 3, negative 6, and 6, negative 12. What is the value of A? So, looking at this equation, I have 2 unknowns. And I have an A value and a B value. Algebraically, to find 2 unknowns, you would need 2 points to create 2 equations. And then use the systems of equations to solve it. That's exactly what we're going to do here. So 2 unknowns needs 2 equations. That's why they gave you 2 points to create 2 different equations. Equation number 1 will use x of 3 and y of negative 6. Equation number 2 will use x of 6 and y of negative 12. I'm just going to call this like point 1 and point 2. So I have x1 equals 3, y1 equals negative 6. I have x2 equals 6, y2 is negative 12. Those are my 2 points. That means equation 1 is negative 6 equals A 2 to the power of B times 3. I changed x and y to become 3 and negative 6, my first point. Equation 2, I'm going to do the same thing, but I'm going to use the second x and y values. So equation 2 looks like this. Equation 2 will be negative 12 equals A 2 to the power of B times 6. Well, my B's and 6's look a lot alike. if we were to clean this up a little bit, that first equation, I would rewrite it like this: a times 2 to the power of 3b. And when I clean up the second one, all I'm doing is making it look nicer, right? I'm fixing the exponent. So instead of the letter going first, the number's going first. It'd be 2 to the power of 6b. Just making it look nicer, that's all. Okay, doing all right? Okay, to solve this, we now need to use like substitution or elimination. One or the other. So this is systems of equations. To me, it's probably going to be better to do substitution. Like elimination is going to be kind of ugly looking just because of the exponent. Like being the exponent, doing elimination is probably going to freak people out. It's probably easier to do substitution here. Okay, to do substitution, you want to get one of the letters by itself. So I'm going to look at equation number 1, and I'm going to get a by itself. To get a by itself, I'm going to divide that power to the other side. So I now have this. I have negative 6 divided by 2 to the power of 3b is a. This means I can go to equation 2, and I now know what a equals. A equals negative 6 divided by 2 to the power of 3b. And I'm going to substitute that in for a. So it should look like this. I have negative 12 equals negative 6 divided. I want to do that in purple. Sorry, give me a second. I just want the colors to kind of stick out. Negative 6 divided by 2 to the power of 3b times 2 to the power of 6b. Okay, before we get into a little bit of a mess, which is solving this thing, how do we feel about our substitution and our systems of equations? I'm just going to give you a minute to look at that, catch up, make sure your notes are kind of filled in. Now's a good time to ask a question. Okay, so what I did, created 2 equations. I got one letter by itself. I chose equation 1, and I chose a to get by itself. I did that by dividing this over. Once I know what a equals, I can use that knowledge in my second equation. I know that a is negative 6 over 2 3b. So I change a to be negative 6 over 2 to the power of 3b. This leaves me with one equation that now only has one type of variable. The only letter left here is b. I can solve one equation that has only one letter, or one unknown thing. I just need to isolate that letter b. To do that, we have to do a little bit of exponent laws, so like reminders of how things work here. So looking at this, these things are multiplying together. Okay, to multiply those things together, negative 12 is just going to stay there for now. I could write it like this. Negative 6 times 2 to the power of 6b over 2 to the power of 3b. Right? Multiplying fractions, the tops just go together. Bottoms go together. Tops together, bottoms, there was no bottom here, so it's just 2 to the power 3. Next thing I'm going to do is I'm going to use an exponent law. When I have two things dividing that have the same base, I can subtract their exponents. This thing right here, those are dividing. That means I can subtract their exponents. So it now looks like this. Negative 12 equals negative 6 times 2 to the power of 6b minus 3b, which is 3b. Subtract exponents. Six b, subtract away 3b, I'm left with just 3b. Cool. Getting b by itself. It's in the exponent. To get an exponent by itself, you have to change it into a log. That's the whole reason logs exist, is to be able to solve exponents. You cannot change this into a log right now. Although that's what I think most people would end up doing. The reason you can't turn this into a log right now is because of that negative 6. Right? You have to have the power, this is my power, by itself to turn it into a log. This is not by itself. This is times negative 6. So I need to divide my negative 6 to the other side. Then you can change it into a log. When I divide that negative 6 over, it becomes 2 equals 2 to the power of 3b. You then can turn this thing into a log. Log, the base becomes the base. Base is 2. The argument goes inside the brackets. That equals the exponent, which is 3b. Log base 2 of 2. You could put that in your calculator if you wanted to calculate it. It's 1. It works out really, really nicely. The reason I know that is because of a log law. Log law says if the base and the argument are the same, the entire log equals 1. If you want to calculate it, in your calculator you have a little log button on the left-hand side, and you hit log 2 divided by log 2, because that's what the base is. And that would tell you it equals 1. That means I now have 1 equals 3b. To get b by itself, I divide that 3 to the other side. That means I have 1 over 3 equals b. Okay. In this cruel question, 1 over 3 is an option for an answer, and it's not the correct answer, because the question didn't ask you for the b value, it asked you for the a value. And it says, what is the a value? We know that the a value is equal to negative 6 divided by 2 to the power of 3 times b. Right? Remember we figured that out right here? That's what a is. But now we know that b is 1/3. So to calculate a, I change b to become 1/3. So a would equal negative 6 divided by 2 to the power of 3 times 1/3. 3 times 1/3 is 1. So this is negative 6 divided by 2. which is -3. That's a hard one. Need a little more space for that one.
Why would they make that like a weird response? If you show them work with other arguments, you still get 0.
Yeah, like if that was a test question, it'd probably be written response. Because you can guess and check your way through questions like that too, which they don't want you to do. You can also graph that at a certain point, which they don't want you to do. So that would probably be written response, and it would probably say algebraically determine the value of A, and it would say that word algebraically.
Is there written response? I know the thing.
They don't tell you how many written responses there's going to be, but there's a certain number of marks that there will be. I think it'll be like, oh, come on, Mr. Kenny, you know this. It's going to be, typically there's 2 questions, and each question I think has 4 parts. So I think you're looking at about 8 bullet points of written response. I think. And I think each one's usually out of 7 or 8. They do a weird thing though on your diploma. Give me a second. Let's start up with log laws tomorrow, but then I want to